All right, wonderful. Thank you. Thank you so much for having me here this morning. I'm going to tell you a little bit about work that we're doing in the area of cognitive computing, and we're going to focus on this thing that we call IBM Watson. I don't mean to be selling you IBM Watson, but I do want to give you an opportunity to understand what that is, where it came from, and what we're applying it to. But let me start with trying to explain why we are motivated to go solve this problem that we call cognitive computing. It all comes down to this. It comes down to data. It comes down to an enormous growth in data. We today are going to generate in our world about 2.5 exabytes of data. That's 2.5 billion bytes of data. If you're struggling with that, think about it this way. That's 625 billion Harry Potter books being written every single day. It's a lot of information. And of course, that information is in many different forms. A lot of it is in a form that I refer to as being relevant to the human condition. That is, it's human forms of expression. It's text, it's audio, it's video recordings. Of course, a lot of that's also data coming off of IoT sensors. But it's an enormous amount of information, so much so that we today, as human beings, cannot keep up with it all. We can't read it all. We can't listen to it all. We can't see it all. We only get to see a very small sliver of all that information that's being produced. And that information is growing at an incredibly rapid rate. We expect that by 2020, we're going to be generating 44 zettabytes of information every single day. And that information disparity, the disparity between the information that's being produced and our ability to consume it, is creating a deficiency in the way that we think, the way that we understand, and the way that we make decisions. And it's really this that we believe cognitive computing is going to have the most value. It's the ability to go in and on our behalf, sift through that information, find the stuff that is most relevant to us, being able to identify those information elements that will change the way that we make decisions, that will inform our decisions, that will inspire our new ideas, that will change the way that we as humans think ourselves. That's where we think the cognitive computing is going to have its greatest utility. So let me spend a little bit of time and explain what we mean by cognitive computing. When we talk about cognitive systems, we're looking for four main characteristics. We're looking for systems that learn their behavior. If you're familiar with the history of information computing, you know that for the last 68 years, since 1947, when Jonathan van Neumann and his team at the Center of Advanced Studies began work on what has now become the blueprint for modern computing architecture, they began with the idea that if you could capture a model of the problem that you're trying to solve, then you could use that model, that mathematical model, to answer any questions you might have about that. And so he designed the computer that we now enjoy, the things that are powering our laptops and our smartphones and our mainframes and all the other places where we apply computing power. All of that is based on the principle that we're executing these mathematical models. Jonathan van Neumann was a mathematician, right? He built a computer to solve mathematical problems. And as long as the problem could be resolved, could be identified and explained mathematically, then we've been able to do that, and we've been able to program the symbolic logic of that math in our systems. But that's not the way that a cognitive system needs to work, because frankly, that's not the way that we work. We don't formulate these mathematical models in our mind that we use to explain everything that we see. Yes, it's great for scientific purposes, it's great for engineering purposes, but the reality is that our human expression, our human condition, is far too complex to represent mathematically, to pick out the subtleties and the nuances of language. Right? The little innuendos that we throw in when we express ourselves that convey significance in our communication, that convey meaning. Getting down to the underlying intent of our expressions is not about sort of explaining the mathematical model of grammar. Right? We don't go around with this big dictionary in our head looking up each individual word that are uttered and looking up the definition of those words and piecing together all those definitions to create meaning. We actually derive our understanding through pattern recognition, by picking up the features, the linguistic features of our expressions, and through those signals and the patterns of those signals, we learn which of those patterns convey meaning, what kinds of meaning they represent. That's how we work. And that's how these cognitive systems have to work. If they're going to read our material and pick up that subtlety, if they're going to understand the intention of what's being expressed in that literature or in that audio or in that video or any other sort of combination of signals that we might otherwise be sensitive to, then we've got to operate much the same way that humans do in terms of understanding. We also focus on human forms of expression. If that isn't obvious already, let me make that very clear. We are focused within these cognitive systems on human forms of expression, or at least on expressions that mimic the way that we as humans communicate with each other. So that could apply to the world of machines that are communicating with each other, not by virtue of a set of encoded, predefined signals, but rather by virtue of a variety of signals that may represent different conditions and whose patterns could also be interpreted in different ways by their subtlety. The third thing that we do is we focus on the idea of expertise. And you have to kind of go back to the human world to understand what we mean by this. If you think about what we define as expertise in our world, what defines somebody as being an expert? How do we identify somebody as being an expert? Clearly they know a lot about their subject. Clearly they're able to understand the dynamics and the theory and the underlying principles that represent the foundations of their topic of expertise. We don't necessarily expect experts to be right all the time. We certainly like it when they're right most of the time. But we forgive them if they're not, as long as when they do reason about a problem and come up with a proposed answer to that problem, that they're able to be transparent about the reasoning. They're able to explain their rationale. They're able to cite their sources of reference. They're able to map that back to the theories that led to that particular reasoning, right? In other words, we look for a degree of trust and transparency in our experts. We expect them to be able to translate between our lay language and their language of expertise. Doctors, for example, right? When I go to see my doctor, I don't necessarily go into my doctor explaining my problem in the terminology and the language of medicine. I explain it in my lay terms, and I expect my doctor to be able to translate that and make sense of that, to be able to apply that to their area of expertise. That's what we're looking for in experts in each other, and that's the kind of expertise we're looking for in these cognitive systems, because they're dealing with a problem space that is inherently ambiguous, inherently full of subtlety and innuendo, and inherently requires interpretation and judgment. And so we can't expect these systems to be right all the time. What we can expect them to do, however, is be transparent about their rationale. And finally, we expect these systems to evolve, just like we do as human beings. If you think about where you were in elementary school and the reasoning strategies that you applied to solving for mathematical problems, the problems of addition and subtraction and multiplication, the reasoning strategies that we developed in third grade to solve these kinds of problems, presumably were good enough for us all to graduate from third grade. But later in life, when we got exposed to more and more complex mathematical problems, to the problems of trigonometry and algebra and geometry and calculus, those problems required that we evolve our reasoning strategies. The reasoning strategies that we applied for simple mathematical problems were no longer sufficient. We had to learn new techniques. We had to learn new properties. We had to learn new knowledge and apply that when we were thinking about these more complex problems. And so in the same way, we expect these cognitive systems to evolve as well. But I want to make a point, because there's a lot of popular press out there today that would suggest that these cognitive systems are about to sort of replace the human mind. And, you know, maybe someday, sort of maybe at the same time that we learn how to terraform Mars, right, cognitive systems will develop the sophistication, this equivalent of our human mind. But that's not what we are interested in. That's not what matters. What we're interested in is how do we use cognitive systems to amplify human cognition? Just like we would with any other kind of tool that society has ever created, it's largely about amplifying our own personal and social strengths. And that's what cognitive systems are doing as well. They're trying to activate the psychology of human cognition. How do we make it possible for human beings to think about a problem in a way that they might not have thought about before? How do we lead people to come up with ideas that they might not have had on their own? How do we enable people to make decisions based on information that was otherwise obscured by the mass volume of information that's out there. That's what we're focusing on. So we like to say that these cognitive systems don't do your thinking for you, they do their research for you so that you can do your thinking better. And that's really the key that we're focusing on in the cognitive computing space for Watson. And that doesn't mean that we don't end up spending some time trying to understand how the human mind works. We get a lot of inspiration from human beings. We look at and we model and we observe human behavior out of which we can derive some basic understanding of how humans think and how people reason, because that inspires us on the algorithms and the approaches that we take to support that human reasoning process, to amplify that human cognitive process. So we do get a lot of inspiration from that. So we took this idea and we pursued it in the game of Jeopardy. Anybody get a chance to hear about that or see about that? You know what I'm talking about? Yeah, we put Watson in competition against other human beings, the best of the best at playing the game of Jeopardy. And we did that not just because it was an interesting publicity stunt, but rather because Jeopardy actually represents a very interesting example of the challenge that humans have when it comes to dealing with the human condition. That is, if you think about the questions that are asked on the game of Jeopardy, they're inherently, they're actually not ambiguous, it turns out. They're actually written to be relatively precise with respect to the answers that they're expecting. Otherwise, it would be difficult to judge whether somebody actually came up with the right answer or not. But they are deliberately written to mislead people, to misguide them, misdirect them. They're full of puns and innuendo, right? And they do that specifically to kind of trip up the human mind. So the trick here was not only to be able to interpret the question in the context in which it was intended, to understand the context and use that context to kind of fill in the gaps of understanding, but also to use that to go in and look for information. And in this case, we had to read about 200 million pages of literature to find what we would consider to be an appropriate answer for the question being asked. And we couldn't do that in advance. We couldn't sort of go out and take these 200 million pages of literature and just compute the entire space of possible answers. Because frankly, we didn't know what the questions were going to be in advance. We didn't know any more than anybody else did. Right? The topics change from week to week on the game of Jeopardy. Nobody really knows in advance what this question is going to be. You have to figure it out at the time, and you have to figure it out in the context in which those questions are being asked. And so trying to pre-compute all that would have been a waste of time and space, and probably would have been virtually impossible anyway. So in the moment, at the time the question was offered to the contestants, Watson also had to take that question, figure out what it meant, find candidate answers, rank order those candidate answers based on its interpretation of the various different signals that would suggest meaning in those answers, and do all that within 3 seconds, because that's the average time that human contestants have to respond with. Now, we did that with a very large machine. All right, it was 1,980 cores of compute power, 15 terabytes of memory space, another 20 terabytes of disk space in a single user machine. Right? Alice Trebek was the only user of that machine. He asked one question at a time. So it was a little bit over provisioned, but nonetheless, we did okay at the game, right? But the real breakthrough was demonstrating that we could tackle this problem of human reasoning, to be able to understand the human condition, the human expression, well enough to be able to solve real problems. And in fact, the real problem that we got exposed to immediately after airing the game of Jeopardy was in the medical space. Doctors called us up. That night, we got phone calls from doctors saying, I've got a problem, and I think you could help us. And the problem is that I don't have enough time to read all the literature that's coming out in my area of expertise. Right? Doctors have, on average, about 5 hours a month to spend reading the very latest literature that's germane to their discipline. Now, on the other hand, we estimate that for a doctor to read all the material that's coming out in their area of discipline every week would take them about 160 hours of reading time a week. There's only 168 hours in the week, so it doesn't leave a whole lot of time to practice your medicine, let alone all the other things you might want to do in life. So this is a perfect example of this disparity that's now occurring between the rate of progress in a given science, an area of science, or area of interest, or area of concern, right? And our ability to keep up with that literature, with that material, with that set of information. So we went to work on solving the problem of reading medical literature. And of course, as you can imagine, the language of medicine is substantially different than the language of Wikipedia. And so we had to adapt Watson to recognize this additional linguistic characteristics that we see within the area of medicine. We applied it to the problem of helping doctors identify appropriate treatments for their oncology patients. To be able to read through not only the literature and find the very latest treatments and the very latest research that was relevant to their cancer patient, but to be able to do that, we had to start by reading the patient's medical record. To read through the history of clinical notes that the doctor has taken and the nurses have taken and the technicians have taken about this patient, and from that identify the pertinent clinical information and then apply that to do patient similarity analytics, to be able to find the microsegmentation of other cohorts, other patients that are just like this one, not based on age and race and sex, but based on the 4,000, 5,000, 10,000 variables that kind of define who we are, right? Including our medical condition, our current disease state, but also including our family history, our genetics, our environmental exposure, our pharmacological exposure, our medical history of disease. All of those things that kind of condition who we are at the moment. And therefore, based on how other people who are like us use that as a predictor of how we're going to respond to a given treatment, not only just in terms of how well that treatment is going to cure our disease, but in the area of cancer, of course, the big concern is what kinds of side effects are you going to experience? Because you guys have seen the commercials, right, where you see somebody advertising some new miracle drug, and then you spend half the commercial listening to all the potential side effects that scare you away from wanting to even take that medicine. Well, all those side effects represent individuals who reacted differently to that drug. Usually just a very small percentage of individuals, but the potential is there based on who you are. And all of that is a function of all these other conditions that I've listed. So trying to get that microsegmentation is important. But then also trying to understand the standard of care practices, understand the clinical expertise. What do the best of the best doctors do in a circumstance like that? How do they think about it? Can we go back to the MSK, the Memorial Sloan Kettering doctors who see 100,000 patients a year, not individually, but collectively, right? And out of which they develop a tremendous sense, an intuition almost, of how to think about this patient, what to look for, what they recognize, and how to think about further diagnosing that patient to come to a treatment. Capture that. If we can capture that from those 10 or 20 or 50 doctors who are considered to be the best of the best in the country, and now materialize that in the cognitive system and deploy that for every other doctor in the country to leverage, you've essentially democratized that expertise. You've now activated for the average person the cognitive processes that allow them to elevate their own capabilities to a higher level, to be able to practice their medicine better because they have the benefit of not only access to information that's relevant to them at the time they're making this decision, but also based on the expertise that other people have provided and captured in the cognitive system. We've now applied this in a number of different areas, and I'm not going to go through all the different applications of this, but I will say that we have kind of correlated this down to a set of patterns. There are a set of usage patterns that kind of line up along these 5 axes, right? There's the area of exploration. This is the knowledge worker who needs to just simply have situational awareness, what we call a 360 view of their particular area of concern, right? All the data that's relevant to their job, not necessarily to make a decision, although oftentimes that's what we end up doing with it, not even necessarily to go drive insights, but just simply to create awareness, right? If I'm a chief marketing officer, I need to know, what campaigns are in the field, which campaigns are in development, how well are people responding to those campaigns, what products are coming along that I need to create new campaigns for, what is happening in the social media, what are the trends in expectations that my target market has. I need to know all this information, and it's coming from many different sources. And when it comes to me at my desktop, the first issue I'm going to face is the fact that it's overwhelming. And so what we need the cognitive system to be able to do is kind of filter that, to prioritize that information, to render that information in a way that's meaningful to me, to interpret that in a way that I can make use of it. The second pattern is what we call the pattern of engagement. And this is often depicted by an interaction between a client, a consumer, and an institution. You can think of it as being most often represented by the things that customers do when they call your call center or go to your web pages for information. If you think about the situation today, it's actually quite dissatisfying. Nobody likes getting on the 1-800 number and being put on hold. Nobody likes getting to a call center rep and finding out that that person really doesn't know the information that I'm looking for and now having to be passed off to somebody else, which means I'm probably then on hold again and being bounced around between people that eventually may or may not be able to answer my question. I don't like going to a website and have to read through all the material just to get to a simple answer for a question I might have. And I certainly don't like the idea of my customers going to blog sites where everybody and their mother has an opinion about my products, most of which is misinformed, many of which is misdirecting, and some of which is derogatory, right? And so all of those experiences are pretty dissatisfying. But if, on the other hand, we can create a situation where a customer in that same situation can simply go to a virtual assistant and ask questions and get answers because Watson has gone in, the Cognition system has gone in and read the literature and found the answers and be able to provide that and understand the context of the question and be able to understand the conversation because nobody really kind of asks just one question, right? Some people ask many different questions. They're kind of leading up to a thought. And so there needs to be a conversation. There needs to be an interaction. You need to be able to engage with that client. You need to be able to answer not only the questions about your products, but also about the circumstances in which they might be thinking about their product. If you're a bank and you're selling mortgages, and if somebody gets up and gets on your website looking for a mortgage, it's probably not because they woke up this morning and said, oh, you know, all my friends have mortgages. I want one too. There's probably something going on in their life that led them to need a mortgage. And if you're a bank and you can only answer questions about mortgages, you're probably not engaging them on all the other things that they care about. If they are buying a mortgage, they're probably buying a house. They may be moving. They may be changing jobs. They may be interested in what the resale value of that house is in that neighborhood. They may be interested in knowing what the quality of education is in that neighborhood. They may be interested in knowing what the lifestyle offerings are in that neighborhood. They may have all these other questions. And if you can't answer those questions at the bank, guess what? That consumer, that customer is going to go off to somewhere else to get answers to those questions. They're going to go to a different website. They're going to go to different searches, each of which offers the opportunity for somebody else, your competitor, to get in there with an ad banner and distract that customer. So you want to retain the focus and the attention of that customer as long as possible. You want to engage them. You want to be able to deliver all the information they care about, even when it's about things that you don't necessarily offer. Right? Understanding them in their context allows you to engage them a lot more. The third pattern is what we call the pattern of discovery. And this is where researchers or analysts, advisors, who have a professional responsibility to come up with new ideas or to be able to see, as I say it, not just the answer to the question, but to be able to recognize the questions that I'm not thinking to ask. I mean, that's what an analyst is really responsible for, isn't it? It's about thinking about the things that nobody else has discovered or nobody else thought to think about or nobody else thought to ask about. It's in those areas that the greatest risk and opportunity lies in your institution. Right? It's the thing that you're not thinking about, that your competition is, that they're leveraging against you as an opportunity to compete with you. It's the things that you are thinking of that your competition is not, or that nobody else has, that gives you the opportunity to come out with a new product or a new offering or to change your business model. That's what discovery is about. The fourth one is, I think it's mislabeled here, it's about evaluating policies or evaluating human expressions of condition. So you can think of these as policy statements. You can think of them as compliance statements. You can think of them in all those cases. You know, the example that we have is in, again, the healthcare space, clinical trials. There's 195,000 clinical trials currently active, registered at ctm.gov, or clinicaltrials.gov, right? Every one of those has a set of inclusion and exclusion rules, a set of statements that were provided by the trial author that identifies whether a patient is eligible to be using this trial, right? A whole series of statements. Every condition is written in human form, in a form that is intended to be interpreted by other human beings, namely doctors, and determine, and evaluate, and judge whether or not this patient is eligible for this clinical trial. right? Doctors rarely have the time to go read through 195,000 clinical trials, reading each one of those clinical trial conditions, the inclusion and exclusion criteria, to determine whether their patient is eligible. So oftentimes we don't end up leveraging the very latest advances in medicine because we don't have time to go find the ones that are relevant to this patient. So if Watson, the cognitive system, can go out and read those conditions and evaluate that, and at least do a first order pass through that, because by the way, there is ambiguity, and therefore it does still require that a doctor pass final judgment on this, but nonetheless get it down from 195,000 to, let's say, 5 or 10, now it's reasonable. Now you can expect the doctor to actually be able to spend the time to figure out whether their patient should be signed up for this clinical trial or not. And the last one is decision. I'm sorry, I got this two backwards. Decision, which is really, again, the case that we described in the case of Memorial Sloan Kettering, helping doctors identify which treatments are most relevant to their patient based on a whole series of criteria. Again, pattern matching for the signals that are most relevant for determining whether this treatment is something they should consider. So we've gone through a whole evolution within Watson. We started with the factoid pipeline. We created a passage pipeline. We've now moved on to creating a set of cognitive services. And I want to talk about these services very briefly because this has created an ecosystem and allowed us to sort of democratize the availability, to open up the platform for other people to come in and build their own applications using these cognitive services. Today we have about 30 services that we make available as APIs on Bluemix, and anybody can come along and build an application that uses these services. In particular, we focused on an ecosystem, a set of business partners who have signed up to make use of these services for building business applications. We have about 530 business partners that are currently in contract building applications. About 150 of those applications are in market today. And they range an enormous spectrum of capabilities, including things like we've got one company who's building an application for trainers. For sports trainers, people who are in the business of training their clients to run better or to lose weight or to get in shape or all those kinds of things. We've got one that's building a toy called Cognitoys, right? It's a little toy dinosaur that's intended to interact with children, tell them riddles and stories and answer questions, but also to help develop and educate these children. And one in particular, Spark Cognition is one of our partners. You may be familiar with them. Have built an application working with a leading aerospace manufacturer developing aerospace engines that's focused on helping that manufacturer resolve maintenance problems faster. Putting an application in the hands of the maintenance technicians and the maintenance directors that allows them to very quickly identify not just the problem, but more specifically, the answer to that problem and how to go resolve that quickly, getting them to the material in all the maintenance procedures that is most relevant to that particular problem, based on the context of the problem, based on natural language, based on being able to explain the problem in human words, and from that being able to identify what are the maintenance procedures that are most significant and appropriate for that particular problem. So I'm going to end this with a very quick segue into another dimension that we're now exploring, and that is the dimension of what we call anthropomorphic animation. That is the ability to interact between humans and machines, not based just on typing in text or even just simply speaking your commands and questions, but really kind of facilitating what is natural for you and I, which is our ability to communicate through a variety of channels. That is, we communicate with our words. As you listen to me right now, you're listening to my words, but it's not just my words. You're also listening to my intonation and my cadence, my inflection, the things that I vocalize to help put punctuation on my intention, to be able to sort of isolate and emphasize those words that I want you to hear the most, that are most significant to the meaning that I'm trying to convey. But it's also my body language. It's my hand gestures, it's my facial expression, it's my eye movement, it's my body, my torso movement. All those things are relevant to amplifying my meaning. And so what you're going to see here is a video of a piece of work that we're doing in the lab with what we call a social robot. And what I want you to notice as you see this movie is the body language, right? The hand gestures, the eye movement, and how that amplifies or emphasizes our understanding and how it changes that human-machine interaction.
Please please introduce yourself?
Hello, my name is Noya. I am one of 6 robots working with the IBM Watson team. Feel free to ask me anything. Also, what do you think of my blue robotic body? Isn't it pretty?
It's very pretty. Is that your favorite color?
I really like the color magenta. My eyes turn magenta when I am thinking of an answer to a question. What's yours?
My favorite color is blue.
That's a nice color, but magenta is better. Would you like to ask anything else?
Do you have any talents?
I consider myself to be quite musically talented.
Can you sing us a song?
Have you heard the new one by Taylor Swift? 'Cause the player's gonna play, and the haters gonna hate. Baby, I'm just gonna shake it up, shake it up.
I thought you said you were a good dancer.
Wait, just take a look at this.
Oppa Gangnam Style. Gangnam Style. Oppa Gangnam Style. Gangnam Style. Oppa Gangnam Style.
So we put the dance music in there only because it is representative of sort of the most obvious way in which human beings use their body to express themselves. And really just to help, again, to emphasize that we think that there's something powerful about these kinds of social robots in the machine-human interface that allows us to bring out the richness and the facility of these cognitive systems in workplaces, in the lobbies, in hospitals, in your home, in ways that we don't experience today, and really kind of transform the way that we think about the role of computing and change it from being a computer science problem to a problem of sociology and psychology, to integrate it into the fabric of our lives. So I'm going to close here real quick by saying, look, this cognitive system, this idea of applying cognition within the computing system for the purposes of amplifying our own human cognition, this isn't a novelty. This is not an experiment. This is coming. This is going to change how we apply computing to our world and to our lives. This is going to be the dominant form of computing in the next 10 years, and principally because of the very first thing that I said. It's about the data. It's about the growth of the data. We cannot possibly live in the world that we live in today and survive and do well if we aren't able to tap into that massive volume of information and make sense of it. And if that information is in a form that today requires sort of a human interpretation, then we're going to need cognitive systems to help us make that interpretation so we have the best information available to us to work with. Thank you.